Hello everyone, welcome back again to Biology Tutorials. In this video, we are going to talk about the first law of thermodynamics. First law of thermodynamics states that energy cannot be created or destroyed, but transferred or converted from one form to another. So based on the image provided below, we have the energy transformation, which is the energy before was transformed or converted into another energy, and this is the picture after. So we have this first law of thermodynamics equation, which express as the change in E, or some of the references use U as our internal energy equals the heat added minus the work done. So this law is often expressed as delta U is equal to heat added minus work, where delta U represents the change in the internal energy of the system, and the Q, or the heat added, is the heat to the system, and W is the work done by the system or on the system. So in simpler terms, the first law of thermodynamics tells us that the energy within a system can be transferred as heat or used to do work, but the total energy remains constant. This principle is fundamental in understanding the behavior of various physical and chemical processes, including those in engines, refrigerators, and chemical reactions. So the first law of thermodynamics is also known as the law of conservation of energy. So for better understanding, let's proceed on problem solving number 1. So example number 1. A 125.6 kilojoule of heat are supplied to 500 grams of water at 22 degrees Celsius. What is the final temperature of the water? So first, we have to write all the given values. So we have the initial temperature, which is equivalent to 22 degrees Celsius. We have the mass, 500 grams, or converted into kilogram, we have 0.5, and we have the heat added na 125.6 kilojoule. So we have this equation as heat is equal to mass times the specific constant multiplied by the change in temperature, or which can be expressed as mass times the specific heat constant multiplied by the final temperature minus its initial temperature, or which can be expressed also into this one. Since we are looking for the final temperature of the water, so the final temperature is equal to the initial temperature plus the heat added over the mass times the specific constant. So by plugging all the values that we have our initial temperature, which is 22 degrees Celsius, plus the heat added, which is 125.6 kilojoule, over 0.5 kilogram as our mass, multiplied by our 4.186 kilojoule per kilogram degrees Celsius as our specific constant of water at 22 degrees Celsius. So by plugging this into our calculator, we get 82 degrees Celsius as our final temperature of the water at 22 degrees Celsius. So that's it. Thank you for watching.